Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast. Kia ora and welcome back to the Passive House podcast. I'm Matthew Cutler, coming to you from Tamaki Makaurau, Auckland in New Zealand, and I'm flying solo this week. And I'm excited to bring you an interview I've had just recently with Barry Cope from ATTMA in the UK. ATTMA is the Airtightness Testers and Measurement Association, and we're talking all about airtightness and how to get airtightness up and running, because that's something that we're wanting to do in this part of the world, in Australia and New Zealand, but it also has been a bit of a journey and continues to be a bit of a journey across lots of countries and lots of areas about how to get airtightness testing more established, not just for Passive House, but also just as really good building practice. So before we get into that, I'd like to do a quick shout out to our sponsors. So thank you very much to our stakeholder partner for the Passive House Accelerator and all the work we do, NYSERDA. Really appreciate their support as our stakeholder partner. Founding sponsors of the Accelerator are 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwool and Zola Windows. And thanks also to our champion sponsors, Buizo, Cascadia, European Architectural Supply, Facro, Icon, Intelligent Membranes, LG and Source 2050. Really great to have all that great support. And special thanks this week to Murray Engineering, who is our Accelerator Partner of the Week. All right, well, let's jump straight into my conversation with Barry Cope. He is based in the UK, but does a lot of work, has been doing a lot of work down in Australia and New Zealand, and is also doing a bit of training in airtightness testing across the US, and as he mentions, the Middle East as well. So here he is, Barry Cope from ATTMA. Welcome, Barry, to Passive House podcast. Great to chat with you. Give us a bit of introduction. Tell us who you are and where you are at the moment.
Yeah, so I'm Barry Cope. I'm the Group Managing Director of the BCTA. You're going to have to bear with me while we rattle off some acronyms, but BCTA is the Building Compliance Testers Association. So we have a bunch of companies that represent different certification programs or certification schemes that operate across the world to some extent. The biggest and most well-known being ATTMA, the Airtightness Testing and Measurement Association. That certification program looks after around anywhere between 82 and 86% of all of the blower door testing that happens in the UK. So well over 180,000 tests a year come through our system. We also have a separate another business called the Sound Insulation Testing and Measurement Association, and that's acoustics and noise control, because I'm also a qualified acoustic consultant, and acoustics is to some extent always been my first love. We also have a ventilation certification program for ventilation commissioning, and we're recording this if you are watching, if we do choose to release this, but otherwise look us up, the Building Performance Hub, which we were just talking offline before we come, inspired by one of Matthew's old haunts in the UK here. So we built a house within a house. We went over to the ProClimber Hub, as it was called back then, and we said we need one of these in the UK. So we built an entire house inside a warehouse. We also have a fully functioning sound insulation suite that's just off camera, ventilation suite, and a 120-seat theatre that we host events in here. So yeah, we're busy.
So it's basically it's a training and event space.
Yeah, so the ATTMA, SITMA, and the ventilation is all about certification and making sure people are doing what they should be doing. And the Building Performance Hub is all about training, events, education, and just trying to kind of improve the construction industry where we can. And
Yeah.
we also host a bunch of people that rent our facility. So we also do air source heat pump training, solar panel installation training. What you can't see behind the house on the other side of the house behind me is a full-blown rooftop solar panel training gantry. So we
Right.
actually get people up on the roof installing solar panels rather than
Nice.
all being all being theory. So yeah, we it's a fun facility to be a part of.
You mentioned acoustics being your first love. How did you get into airtightness in the first place?
Good question. I studied engineering when I left school. I did an engineering apprenticeship, and it was old school engineering. You don't get much of it these days. It's all computer aided design. You stick things in computers. But back then it was milling and turning and lathing and filing. And I got placed with a company called Oxford Instruments Analytical, and they make electron microscopes. So I ended up then studying in a kind of high performance manufacturing world, and I wanted to work for them and be a field engineer because their field engineers were going all over the world. They were going to Japan, they were going to America, they were traveling to install and fix the machines that we were making. And I tried to, it came to the end of my apprenticeship, and there wasn't the role for me. I was offered a role at the business that just wasn't right for me. So I, uh, I Googled field engineer, and this new thing called airtightness testing had popped up, and I submitted my application on a Monday. I think I interviewed on a Wednesday, was offered the job on a Friday, and started the following Monday. So
Wow.
within a week, I'd gone from rubber gloves and clean rooms to full blown building site. And that air testing had kind of just dropped into the building code in the UK, but wasn't really being adopted. It was very much we had to wait for the next round of construction to go through the planning system before air tightness was mandatory. So I was in there very, very early. And that was it. That was how I got into air tightness testing. I was in the field, you know, sometimes knee deep in mud, doing blower door tests for builders who had never heard of it, were terrified of it because it was now written to the building code, and kind of perfected my craft, as it were.
Yeah.
I'm, I'm pretty terrible at it now. I actually tried to do a blower door test on the house behind me and tried to install the fan, and I'm rusty to say the least. I was not as
Yeah.
quick as I.
Well, the industry's come a long way, and lots of very competent, very experienced people doing it on a daily basis now. Partly because of the work that you do. You mentioned 180,000 tests in the UK. What else does ATTMA do as an organisation?
We moved. We were a trade association. The big thing that we did originally was write the test standards. So we took what was a very bland international standard for air tightness testing, ISO 9972, and kind of one of the ways that ATMA had its success was that we took that standard and we turned, I think, what was maybe 10 pages into 80 pages. And it said, here is how you do a blower door test. Here is what you need to look out for. Here is how you do the math. And we turned that into a big practical standard. So the test standards and setting those standards has always been a big thing for us. And we're very proud of the ATMA technical standards. They actually, at one point in the world, they were listed in the building codes of 80 different countries as our technical standards, which was wild. Now, and that's reducing due to politics and due to other standards actually getting a bit better and covering off some of the stuff they had failed to cover off. So that's the big thing we do. We set the standards. We tell people how to test awkward buildings, or we help them. We teach them. The other big thing that we do, and sometimes I describe ATMA as an IT company. We invest heavily in our IT system. So we have our lodgement system. And our lodgement system is a system where you record or you send the data to us for every single blower door test that a certified member does. We then analyze the data, and if everything's okay, we kick out a single page certificate. That single-page certificate can then be handed to the code inspector, and because it contains that ATTMA logo, they just trust us. They trust that ATTMA is looking after it. That means the tester is insured, the tester has calibrated equipment, the tester must have submitted the correct data, and we create that level of trust, and it creates a very seamless and smooth industry. Tester
Yeah.
tests, submits data, receives certificate, issues certificate, and we
Right.
look after everything behind the scenes. And on top of that, we've developed the lodgement system. We now have the ATTMA app, the ATTMA testing app. So currently on Windows, iPad, and Android, you can download, if you're a member of ATTMA, the ATTMA testing app, and we allow testers to use that, and you can connect. I think technically you can do an unlimited fan test, so you could do a 200 fan test as long as your device has enough memory, and you can run those blower door tests or those fans off of our app, and we don't charge a penny for it as long as you're a member.
Right.
Some of the software is very expensive. We're talking thousands of dollars, and we have ours fully integrated into our lodgement system. And the cool thing that comes off of the back of that, and the reason I talk about that, is because some of the stats that we're about to release are linked to auditing. So, on average, some of the other softwares, and I won't go into, I don't want to get myself sued. Some of the other softwares have an average of 6 to 8 non-compliances because of various little things, and the average non-compliance rate for an ATMA test is we typically pick up one thing or a recommendation of one thing. So it's kind of
Right.
8 times less risk or 8 times less potential problems of failing an audit from
Yeah.
our crew.
So
Because
that software work with any type of door that somebody might, or any
yeah,
type of equipment.
we actually yeah. So I put a video on LinkedIn the other day, and it showed the we had a energy conservatory fan, a DG1000, which is the energy conservatory gauge. We also had a Retrotec 5000 series fan and their DM32X, both connected to the app, running simultaneously fans at different pressures with different rings. So we never set out to do that. It's just something that just works on our app pretty nicely. So you can connect any gauge to it, even down to the old DG700s, as long as you have the little Bluetooth adapter. It works on Wi-Fi. It works directly via USB cable, and it's out there as long as you're a member of ours. You can use it completely for free because it
Nice.
automatically lodges the test whenever you're done, comes through our system, gets the check, and gets released. And that's kind of why ATMA is. I think it's why we've been quite successful, is because we offer that seamless approach. We
Yeah.
look after the blower door industry, and we stop things going wrong before they go wrong, as long as
Right.
you're using within our framework.
Yeah. You mentioned checking things once something has been lodged and then you push out a certificate. What, how does that check work, given that you're not on site and checking the measurements or the doors installed correctly?
Yeah,
What can you
two
check
things.
that's just submitted?
So as part of your certification, you have to maintain your own records. So that's a record of the plans of the building. That's a record of any photographs for the test, any your how you calculated the size of the envelopes. That maybe
Mm.
you write it down on paper. That maybe you use SketchUp, is a very popular tool. Uh, you need to keep a record of that. And what we do, not quite at random, but almost at random, is we look at every tester every year and we pull reports from them retrospectively, and we recreate the envelope areas from those tests. Now,
Right.
granted, it's not a perfect science because we're not on the building, and construction they always add 600 mil here and 200 mil there, and that's why
Yeah.
record keeping is so very important. Because if we work from the original plans and the tester hasn't identified in their own documents that the test is different, or there's a change from the plan, then they'll get themselves a non-compliance and
Yeah.
eventually warnings and kicked out of the certification scheme. So
Right.
it's really important that the testers' records are very, very good, because we do pull them and we do kick
Yeah.
people out if they're seen to be doing wrong.
So today there's an industry quite well established, good quality control, good industry association through ATMA. That wasn't always the case, and as you mentioned, when you first got into blower door testing, it was just getting started. How has the UK got from where it was to where it is today with regards to airtightness in the building industry?
Uh, Good question. I believe that, and I think we were the first country in the world to move to 100% blower door testing. It's every apartment, every house, every building, every commercial building. We're the first country in the world to do that. It started in 2006, when we were part of the EU. The Energy Performance Buildings Directive came out, and that said that you have to start looking at the energy performance of your buildings. It's a European law, and the air tightness testing was this new technology. And I think honestly, somebody in the government just took a chance and just said, this is a great way of monitoring or reducing energy load. This is a great way of reducing heat loss. It's a great way of controlling humidity. It's win, 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 as far as we can see. The only potential downside is ventilation, and we'll talk about that, I'm sure. So there's maybe 5 upsides, 1 downside for air tightness. That's not really a downside. We just have to manage it. And that is how somebody said, right, well, let's do a sample of buildings. Let's see how airtight the buildings are. I think the average back when I was originally testing was 1 in every 10 or something buildings, 1 in every 8 maybe. And from there, what we realized is that the sites got very clever, or some sites got very clever, and they were what we would call dressing up plots. So they knew plot 22 was to be tested. That would
Right.
be sealed and looked after, but the rest weren't. So the regulations in 2010 tightened that. So they said, now you have to do more testing. So it went to, I think, about an average of 1 in every 3 or 1 in every 4, depending on the site. But also the ones that you don't test get penalized by 2 meters cubed per hour per meter squared. And therefore, if the ones that you test, if everything on the site needs to achieve a 5 meters cubed per hour per meter squared at 50 pascals or less, the ones you test should need to achieve 3. And we went through this whole cycle, and we were only just coming out of the other end of that, where the builders had come from quite a high number to quite a low number in quite a short space of time, and they realized it wasn't achievable. So that same issue was still happening. These plots, the process wasn't clean. And again, somebody in the government took a chance and said, I'm fed up. It isn't working. You're now going to test everything. And
Right.
the
Yeah.
lobbied and said, what's the point when most, or not most, but a good chunk of the national house builders that would build, anywhere from 500 to a couple of thousand plots a year were testing 100% anyway, because they didn't
Mhm.
want to have to deal with the penalties. They were just testing them all anyway. And I think the
Right.
industry at that point just realized, hey, the cost of a blower door test on average, if you're doing large building sites, was maybe, I don't know, £60. I'll help convert that. That's maybe $80. That's maybe something like 100 New Zealand dollars, and pretty close for Australia as well. So
That's unbelievably low. I mean, how many tests would a tester do in a day?
anywhere anywhere they typically load up their day. So a typical tester on a typical day could theoretically do as many as 15, but realistically you would be doing 4, 5, 6 maybe. I remember a very stable period where all of my guys that worked for me were doing an average 6, 7 tests per day.
Yeah.
So actually starts to add up if you can do that 5 days a week,
Yeah.
and really
And that, I guess,
get those
helps bring
numbers.
that price per test down quite considerably as well.
Yeah. And at that point, the air testing world had changed. So in 2010, the air testing world had definitely changed a lot. It went from people with physics degrees, which is kind of where Australia and New Zealand is now. You have these
Yeah.
incredibly educated building scientists that go out and do the blower door testing, and they absolutely love it. And what happens in any industry is the more testing that happens, the kind of education changes, the training changes, and the world adapts around it. And you then start having a lot more tests being done, because people realize actually a blower door test, if you're just testing to achieve a number, it's actually quite straightforward. We're not
Yeah.
doing anything really difficult here. We're moving air around, And naturally, the building scientists move up in the ladder. They become the managers of the businesses. They retire sometimes, and the youngsters. And I know we shouldn't say youngsters, but the youngsters tend to come up through the ranks, and they have a lot more energy to get on the sites, and they do lots of blower door testing, and typically they're paid a lot less. And that cycle we've been through a few times in the UK, where I haven't ever looked at the average age because we don't store that information, but the average age of a blower door tester is a lot younger than it used to be,
Yeah.
and the market changes. And actually, I've got kind of that forms part of my presentation that I'm delivering uh, to the New Zealand crowd on Monday. I think it is Monday for me, Tuesday for you, next week, which talks about the kind of transition from, as a country looking to get into blower door testing, or trying to convince the regulators it's a very good thing. Actually, it kind of makes sense. You have to not think every blower door test is always going to cost a few $1,000s, because the industry will change and adapt naturally.
Yeah.
You can probably
Yeah.
pick anything in the construction industry that is the same. If you take, I don't know, I'm thinking too much now, but if you take any of these commodities or industries, if you take electricians, there's the market adapts around the supply and demand.
Yeah. Um, but how do we go from zero essentially? I mean, we're slightly above zero at the moment to getting a blower door industry established.
I'm glad you said that. And the same thing I get asked a little bit about. I get asked a lot of questions about this, and there's one word that always comes up, and it's risk. The reason lots of countries don't do blower door or have it as standard in their building code, or options to avoid it, is just simply this perceived risk. And it comes from having their fingers burned sometimes. I know in New Zealand you guys had the pink bat, is it the pink bat syndrome, uh, where someone in the government makes a decision and it has unintended consequences, and those unintended consequences cause building sickness or building problems. And airtightness has this has just something associated with it. People think of airtight homes as stuffy homes, as
Hmm.
homes that retain heat and make it uncomfortable. And people say, if I had a pound for every time someone said to me, houses need to breathe, I'd be a multimillionaire, honestly. Houses need to breathe, but they need to breathe through controlled, measurable ventilation, not through uncontrolled infiltration, which only happens when the wind blows in the right direction.
Yeah.
And that the problem is it's risk adverse. So right now in New Zealand, I've met a bunch of the cool guys from MB, and they're just concerned. And the same in Australia. They're just concerned that if they suddenly make houses airtight, they're going to find issues with increased humidity, and then mold when the cold sets in, and it's going to ultimately end up in people getting sick. But my counter argument to them is, hey, if you make your homes airtight, people can actually heat them for less money, and they're less likely to get sick because they're
Yeah.
not sitting in a cold 10 degree, 40-degree Fahrenheit building because they can't
Yeah.
afford to heat it. Or when they turn the heating on that they do have, it doesn't do anything because the air just gets sucked outside.
Yeah.
Whereas I know from my experience with America, it's if you have a really leaky home, they just put in a bigger air conditioning unit or a bigger heater and
Yeah.
overcome the air tightness. It's like blowing up a balloon with holes in it. If you just blow harder, you maintain the air in the balloon, and that's
Yeah.
wrong. We
Yeah.
shouldn't be
Yeah.
saying, hey, let's put in bigger air conditioning units and bigger heating units. Let's plug the holes in the balloon, and
Yeah.
suddenly
Yeah.
we won't have to put as much energy into it.
You mentioned the moisture control as well as being one of the advantages, and I understand that, but I also understand how that can be counterintuitive the first time someone hears that, because they think airtightness equals stuffy, you're going to have moisture
Yeah,
problems.
that's certainly a thing. In the UK, we don't tend to have moisture problems in our buildings. We
Right.
do and we don't, but not from the weather. We're quite a temperate climate. We're not overly warm, overly cold, overly
Yeah.
humid, or under humid. So actually, it tends not to be a problem here. But in in certain places, particularly coastal areas. I mean, you can look at basically anywhere the majority live in Australia,
Yeah.
substantial parts of New Zealand,
Yeah.
substantial parts of South America, south of the USA,
Yeah.
South America as well. But I've never managed to go further south than the USA. They have extremely high humidity, and then they have air conditioning on the inside, and naturally,
Hmm.
humidity wants to travel from the outside in. If you don't control two things, if you don't control your air tightness layer and you don't control your air barrier layer or your weather barrier, then you end up with humidity or humid air working its way into building cavities and then condensing. So the temperature inside those walls is much colder. And if the moisture then comes out of the air, settles on building, particularly in timbers, then those timbers will start to rot out. So
Hmm.
having those air barriers and weather barriers is super important. We don't tend to get it here, but having an air tightness layer helps to substantially control that. Uh, on top of having the appropriate weather barriers that allow that moisture to escape in the right direction. You don't want it coming into your home and working its way into your dry lining, into your plasterboard, and because ultimately it will develop into mold, and you end up scraping it off
Yeah.
or painting over it. So humidity is really very important in countries that do have a high humidity climate, and it's substantially underrated in terms of building longevity. I was looking at some stats with our quality manager here, Phil, and it was looking at the number of occupants in New Zealand versus the number of house builds per year. And therefore, you can figure out the kind of lifespan of an average home, or at least the last generation of homes. And in New Zealand, they build a home every 30 years for each person on the
Right.
island.
Yeah.
So number of house builds divided by the number of people, it effectively works out as every 30 years you're replacing your homes. Whereas in the UK, we're closer to every 100 or something. And
Really?
that's
Wow.
actually, yeah, and maybe I'll need to check my numbers on that, but it's an incredible stat. That means you're not building sustainably, you're building until your buildings rot, pulling them down, popping a new one back up. And that's not
Yeah. Yeah.
sustainable.
Yeah.
It's
Yeah.
sustainable if you're a builder.
You
Great.
might you might be skewed by having a few buildings that are older than our country post colonizations.
Yeah. Let's
Yeah.
yeah.
Um, so I want to come back to establishing the industry because you've got airtightness now in the codes, part of the compliance pathway. Can people self test? Like, do builders have their own door and they do their own tests, or do they have to get someone independent?
Generally
How does it work?
generally depends. In the UK, they only tend to have their own blower door kit if they're building passive house or Enofit or something with a very, very low leakage rate.
Right.
But they can't sign off the final, well, they can technically sign off the final build, and that's not quite true. The current code pathway in the UK is that we operate with competent person schemes. A competent person scheme is a certification program that allows trades to self-certify work done for building compliance purposes. So,
Yeah.
for example, if you're an electrician, you can belong to a certification program, and therefore you you are able to produce certificates that go to the building inspector, and they trust that because you're a member, you're then certified, you're inspected, you're audited, and that's the pathway for more than 99%. You can technically do your own blower door test as a self builder and submit that information to building control, but you do
Yeah.
need calibrated equipment in the UK. You do need to use the approved test procedure. You do need to be able to demonstrate competence as part of not using a competent person scheme.
Yeah.
So therefore, it doesn't tend to be a very popular route. In other parts of the world, I'm not entirely sure how it works in the US. In Australia and New Zealand, we operate a version of our certification program out there. So we have ATTMA ANZ for Australia and New Zealand, and we have a good chunk of membership now. I think we're best part of 100 people that have blower door kit, that hold insurances, that are fully signed up to the program and doing
Yeah.
tests for other building certifications like Passive House, LEED, BREEAM. I can't remember if there's any others that kick around. So there are there are some pretty active testers in New Zealand under the
Yeah.
ATTMA system, and some pretty active ones in Australia.
Yeah. Um, and what do you see coming down the line? What's on the horizon in terms of new technology and new either hardware or software?
Honestly, there are loads of things that are kicking around. There's some of you may have heard of Pulse, the low energy Pulse method, and that's a compressed air tank that releases and tests buildings typically at 2 to 4 pascals of pressure, whereas a blower door we average around 50. That has its uses for fast compliance or
Hmm.
retrofit. For example, if you need to go and test 50 homes, you can test them pretty quickly, but it doesn't give you doesn't tell you where the building's leaking. It's fast.
Right.
It's a fast compliance tool.
Yeah.
They're having some success in the UK. We have some questions about some of it. It tends not to be a popular tool because it's the majority of tests. People do kind of want to know where it's leaking because it's always a
Right.
learning curve, especially
Right.
as it's getting tighter.
Yeah.
There's ultrasonics. Is it ultrasonics? Very, very high frequency wavelength stuff that's coming out where you have a speaker that produces somewhere between 10,000 and 20,000 kilohertz signal, and you can then receive that signal the other side of a wall, and theoretically the wavelengths are so small that they'll make their way out of wherever there's a building leak. It's not really a tool for domestic testing, but it is really very good for curtain walling. So at the uh, any building you have a very large chunk of curtain walling, it's actually quite good for that. Uh, but then on the flip side, whenever it's discussed, the builders say, yeah, so is spraying a hose. You could just spray water at the window and where it leaks. And it's not
Yeah.
quite as true because it will pick up if you need to create a very low energy building, it will pick up holes that hose bar spray testing won't quite pick up just because of
Right.
physics.
Yeah.
Uh, that's
It probably
coming
doesn't
out.
make as much mess either.
Yeah, but otherwise, what's happening with the blower doors is that they're getting smaller. So now I probably should have picked one up. The Energy Conservatory duct blaster. Uh, I think it's sometimes called a mini fan in other countries. That is now capable of testing more than 95% of the homes in the UK. The mini fan. That's it.
And
95%
is
of all
that
the homes.
because the homes are getting tighter?
Yes.
Yeah.
So the homes are getting much tighter. The average air tightness now in the UK is 4 meters cubed per hour per meter squared at 50
Right.
pascals. Uh, Nothing to be crazy proud of. Though a lot of nations are doing better than we are. We just test more.
Right.
But what it does do is allow the it's so lightweight. You don't need a van anymore. You can just have a car.
Yeah.
You don't
Yeah.
need you can put it in your. I used to take them in my backpack and get the train to London and do my day's
Right.
test with the bow and arrow style
Yeah. Yeah.
case because it's so light. It's so
Yeah.
small. Minimal minimal anything. You don't even need a laptop. You can now test using your mobile phone. You can do all these things that you couldn't do. So the technology of fans isn't really changing, but they are getting smaller and more powerful. The
Yeah.
Retrotech have just released their 7000 series big fan, the big blower. And that fan is now the equivalent of when I used to set up a 3 fan rig. So I used to have 3 fans in a doorway stacked on top of each other. We're now talking nearly 20 years ago,
Yeah.
stacked on top of each other, blowing air into a warehouse building just like this one. And nowadays, there's a singular fan that can achieve the same flow rate with 1 fan with a
Right.
much
Right.
template go in. And
Yeah.
therefore, again, you don't need to carry around hundreds of fans. You can do
Yeah.
much bigger buildings that are much more airtight with much less equipment, and
Yeah.
that's certainly a good technology. But ultimately, a fan is a fan. It blows air in, and the air escapes wherever it wants to escape,
Yeah.
or suck air from the outside into the building.
Yeah.
It's simple. It's so simple, but so powerful. It's really easy to well, it's not easy to create these fans, but the technology of these fans is just to go bigger and more powerful, so you can use less of them, or smaller, so that you can try and keep these things nice and compact
Yeah.
rather than on heavy fans.
Now you've mentioned the unit meters cube per meter square per hour. So permeability as opposed to air changes. Is that the preferred and common unit now being used in the UK?
Yep, always has been. We've always used the air leakage, or the amount of air coming through the fan or held in the building at 50 pascals in meters cubed per hour, and then we divide that number by the surface area of the building.
Yeah.
I know in a lot of other countries they use ACH, which is, they would say, air changes per hour, and that's simply just the amount of the air coming in. Instead of dividing it by the surface area, you divide it by the volume, which is how it's done with Passive House. So you have ACH or ACH 50, and it works. It's pretty much the same. We have a wonderful graph. I'd love to share the graph, and if you do release this as a video, you can pop it up on your screen. But we tracked. We now have 1.5 million air tightness tests in our lodgement system. So we
Yeah.
tracked and looked at the volume compared to the surface area, and you can actually see the crossover point. So if you test a very, very large building, let's take one of these monstrous warehouses that's springing up all
Hmm.
over the world. Because the volume compared to the surface area of the walls and floor and ceiling is so much larger, by using volume, you get you don't quite get a sense for the true air permeability. So I had somebody email me the other day, a guy called Ben Scales from NABCTA, and he said, "Wow, look at this! Look at this Amazon warehouse. This is amazing. This got this really low air changes per hour figure."
Yeah.
And I said, "Great, it was great, and it really got a really good result. But hear me out. When you convert that number into permeability, it's actually not as good
Yeah.
because it's just the way it works. And actually, there has been some lobbying, I know, of the passive house industry to start using permeability because
Yeah.
it's a much more stable metric. It doesn't give you almost a freebie, as it were, if you do really very big buildings. But then
Yeah.
I can also see the air in the middle of the building wouldn't necessarily escape, so you could counter argue that. But I'm a permeability man, always have been,
Yeah.
and I would lobby that every country in the world uses permeability, not
So yeah. Yeah. And what is the current requirement in the UK?
current requirement is, or the backstop. We would call it the backstop. So the very worst you can achieve is actually an 8. But we have an energy model that has to be done on every single home, and that energy model is a trade-off. So at the end of it, you're looking at CO2 emissions, and you're allowed certain amount of, I think it's kilograms per something. I should know that off the top of my head. It's quite late here because we're
CO2
recording.
equivalents per
So
meter
yeah,
squared or something. Yeah. Yeah.
it's a trade-off. So the more insulation you add, then the more you save, the more solar panels you add onto the roof. It's a big
Right.
trade-off. It shouldn't be a
Right.
design tool. It was never intended to be a design tool, but it is. Uh, so therefore, the worst air permeability you're allowed in the UK is 8.
Yeah.
The the average is actually 5 as a target, and the average achieved permeability is currently 4.01
Right.
as
Right.
I look at that
So people
stat.
are recognizing that the benefits that has to their energy model, which is also then translates to their carbon output.
Yeah, and because of our compliance model, you have to have an air tightness test anyway. Then
Right.
the natural thing for the SAP assessor for this is to take down the air tightness. You're paying for it anyway. You're
Yeah.
building anyway using the same
Yeah.
materials. I
Yeah.
suspect you have this argument a lot, and a lot of your audience for the passive house
Starting
community
to, starting to, yeah.
you're using the same materials. You just need to use them in a slightly more
Put them
controlled way.
together
And
better.
actually
Yeah.
the costs aren't always, there's a perception about passive house that it costs substantially more. Uh, and I think largely, at least in my experience, it costs more, but not substantially more. And the
Yeah.
benefits you get out of a passive house
Yeah.
are a lot better than the code.
Yeah.
So
Yeah.
yeah,
Um, Awesome. I appreciate it is late. So better wrap up. Where can people find where is ATTMA active at the moment? You've mentioned Australia, New Zealand, UK, in other parts of the world. I know you're going to the US yourself. You do a lot of training over there. Where else do you get around?
mainly Mainly those. I mean, Middle East is pretty big for us. I've had an inquiry to go to the Middle East in a couple of weeks.
Yeah.
They use the ATMA standards. They also use a lot of the UK building regulations. So they
Right.
look and they say, rather than recreate the wheel, let's just point to what the UK are doing, and
Yeah.
that means naturally we fall in line with their requirements. So you need to be a member of ATMA to operate under some of their certification
Right.
programs.
Yeah.
Pretty so we operate from the Middle East. We spend a lot of time there. Australia, New Zealand. We have members in Malaysia. We have members in across Europe, Poland, Latvia, Spain. We tend not to have too many members. We don't have any in France. France is a big blower door country right now. I think they have 1,000 blower door testers employed doing testing all day, every day.
Wow.
They are testing everything. Germany, not so much. And surprisingly, Scandinavia doesn't have as many testers. I think a lot of people think up in Scandinavia, Norway, Finland, they must do loads of blower door testing. They don't. They
Yeah.
just build properly. They,
Yeah.
you know about it when it's -40 outside and you've
Yeah.
built a
Yeah.
house
Yeah.
of
Yeah.
coals.
Yeah.
Yeah.
You also have a podcast. Where can people find that?
Yeah, so if you look up the Building Performance Hub podcast, we have so far released, at the time of recording this, 5 episodes. We've got 3 more in the pipeline recorded and ready to be released. You can find that on all of the normal podcast providers, Amazon, uh, Apple, Apple Podcasts. You can look us up on YouTube. We record everything we do, and you can see we record it mainly from this location I'm sitting in right now. If you do release this
Yeah.
on video, so look up the Building Performance Hub podcast. I'd love to have you on, Matthew, on our podcast and
Love to.
chew the fat about Passive House, because I've got
Yeah. Absolutely.
some of my guys that would love to talk about the technical side of Passive House.
Sure. Hey, well, thank you very much, Barry, for your time today, and also for sharing the journey and transferring all that experience and knowledge from the UK and get it out. We've got a long way to go. Similar journey. My aim is to try and accelerate that so that we can get to a point similar to where you are today, and ideally not take 20 years to get there, and improve the building. So, looking forward to having your continued input down this part of the world. So I appreciate that. Thank you very much.
No worries. Thank you so much for having me.
And that was Barry Cope from ATTMA, which is the Airtightness Testing and Measurement Association based in the UK, but active all around the world. Really involved in training of and promotion of airtightness and training people in their standard, and also operating that fantastic lodgement system that they have now, over 1.5 million tests in that lodgement system. So incredible amount of data, not just on the trends of blower door tests, but because they include in that things like the area and volume of buildings and the amount of insulation those buildings have. It's actually a really rich source of building performance and just building information as well, which is an incredibly useful resource now in the UK, just because of those sheer volumes. And I'm excited to try and grow that in this part of the world as the industry evolves as well. Really interested about that leverage point of identifying risk, because people in the passive house world kind of want to promote everything around energy efficiency and comfort, and the benefits of airtightness testing, or the requirement for airtightness testing. But the benefits of an airtight building are so much more than that, particularly when we consider things like acoustics, smoke, fire, pest control, and also just checking the quality of the building. And I often say to designers here that there's no other single quantifiable metric that you can use to assess how good a building is put together, other than visual inspecting. There's a lot of subjective interpretation of building quality, but a blow door test is a scientific, repeatable method of checking the integrity of the building envelope. So for that reason alone, it's a fantastic thing to do. And really interesting, of course, that the UK is now one of the first places in the world, as Barry said, that requires 100% of new buildings to have a blower door test. That's pretty phenomenal, but it makes it very clear cut. You don't have to have complicated rules deciding which buildings are going to get tested and which aren't. You just say, test them all. And then the industry evolves to make that very cost effective, and it just rolls into part of general building practice. I think that's a great vision of where we want to get to. Our challenge here and in other parts of the world is to figure out the pathway from getting to where we are now, which in our case is right at the early stages of airtightness as a concept, um, for it to become commonplace and just standard practice. We didn't get too much into Barry's training around the ventilation industry, but as part of the Building Performance Hub where he's located, they do a lot of training on ventilation, installation, and commissioning as well, which I'm very interested in. And it goes so well hand in hand with airtightness testing. So really great work. Check out the Building Performance Hub, which is what Barry's been working on the last few years. Fantastic facility that he's got there. And you can also look up the other work that he does, and also check out that Building Performance Hub podcast to hear more of Barry's work. All right. Well, thank you very much for tuning in. Don't forget to jump on over to the Reimagined Building Collective and check out all the great courses there, including the Honeybee Passive House course for passive house modelling by the fantastic Ed May. That will be available, if it isn't already, very, very soon. And it's yet another great reason to jump in and join Reimagined Buildings Collective. This Friday, we are talking designing for fire resilience on Passive House Live. So check that out. As always, you can find out all the upcoming events on the Passive House Accelerator podcast. That's it for me. Thank you very much for tuning in. We'll be back again next week on Passive House Podcast.